Hey everybody, what is going on? It's Alexander Williamson here with number 168 of FISHTORY, and I want to thank all of you guys for supporting this channel, for supporting what I do. I can't believe we're at episode 168 already, but we are, and thank you if you're watching on the Aquatic Morning Show. If you're watching on my channel once this has been released, I want you to know that you can watch this a little early, and we're in black and white. I'm trying it out to save data and bandwidth, compression and everything on the video, so that hopefully if you're listening to this mobily or on the car, it doesn't use up as much data or also bandwidth in the house if others are watching things. Just because this is not a video format, or it doesn't need to be. If you guys want to watch me talk, you can feel more than free. I know, like on the Aquatic Morning Show, you have to watch me. So, or maybe you're going and getting your snack. Whatever it may be the case, that's what's up with the black and white, and it's something I'm going to try to remember to do. But today we have something really, really crazy to talk about in fish news, in fish history as well. And you guys allow me to do that by being members, by getting the sneak peek and things, but I really don't like hiding these stories behind paywalls, and so that's why I've decided also that, you know, for $1.99 you get all these stories for the week and their history, their new discoveries, new fish species, new research, everything from material and data science to ecology, biology, to aquarium economics, whatever it may be. It's tied to our hobby, to fish, and our culture at large. And all of those things are then cited, and there's lots of sources and other interactive links a lot of times that come with this and are not in the description and whatnot. Usually they're in the community tab on my channel, where you guys can access them, because I can post a whole lot longer posts in there and embed links and things like that easier, as well as photos too. So I hope you guys will visit the community tab, especially if you want to support the channel as a member. It's only $1.99, and then you get that behind the scenes access a little bit ahead of everyone. But as I said, I just can't in good conscience hide knowledge that I wanted to make available for everyone. So some of these are going to be open to the public, and that's this one this week. So sorry for the long spiel at the beginning, but let's get into this. There's not a ton to say about today's episode, and that is that the world's largest freestanding aquarium has been destroyed. It imploded, or really it did the opposite of that, but I can't say that without getting the video limited. It will shadow ban the video if we talk about the opposite of imploded, outward. But that's what most of the story headlines are saying, and it was a giant 52-foot tall cylindrical aquarium in Berlin at the Aquadome, and that was essentially a spectacle piece, the largest freestanding aquarium in the world, built in 2003, and it was home to around 2,500 or so rare fish and countless other corals and shrimp and crustaceans, all living in this giant cylindrical tank. And there was an elevator in the center, and this whole thing was in the center of a Radisson courtyard, or I guess you'd call it an atrium, in Berlin, in a hotel. And then further down the hall in the basement and adjacent to the building, there's also hatcheries where they were trying to supply their own fish for this, so that they wouldn't have to use wild caught. They were doing all sorts of conservation projects and really making a difference in what's going on in saltwater fish keeping, but also freshwater and European fish keeping. And some of those facilities were flooded, but luckily it sounds like most of the hatchery sections and research sections were spared for the most part in the basement. The water literally was moving so fast, and there was so much of it that it kind of went out as waves out the first floor through windows, shattering the windows and going through doors and windows, doorways, and spilling out into the street in Berlin, where it was like -8 Celsius. So, I mean, we're talking like 20 degrees or less at night, and the fish were literally frozen within a matter of minutes if they didn't just suffocate. Now, when you're looking at big fish like this was, some of these fish were, you know, almost 2 or 3 meters, or, you know, 9-foot long sharks in some cases. And when they're out of water, they can last quite a while. Their blood's quite oxygenated as a creature of that size. And so, unfortunately, it was a very gruesome sight for them to all spill out and, you know, be also cut up by the acrylic slash. That I've seen it referred to acrylic, I've seen it referred to glass, but it sounds like it was some sort of Pyrex type, almost like a bulletproof glass type thing that they used, a special acrylic they engineered and used with it. If you guys know more about it, though, I'd love to know more, because it's kind of limited info, other than the fact that it's coming up on 20 years, and they were recently remodeling it, but this happened in the middle of the night, thankfully. Something like 2:30 or 3 in the morning. There was a critical failure of the we're calling it glass for lack of specific knowledge of the material, and it just instantly, the entire circumference of the base failed and went into thousands of tiny little pieces, as well as some large shards too. 2 people were injured cleaning up after the mess, and they still don't know what exactly caused it. I believe they will have security footage as well, CCTV footage, but it has not been yet released. So that'll be interesting to hear and or see what comes of that. But there was actually a bar at the bottom of this giant fish tank. There are rooms all around it, and amenities, things like a work center, faxing and copying type stuff for business stays, as well as check-in desks, and also kind of like an atrium, it sounds like, with some sort of dining options available as well. And luckily, no one was in there. It was 2 people injured that were cleaning up the site afterwards. Now, a lot of people have reported on the fact that 1,500 rare and large saltwater beautiful fish passed away. But between 400 and 500 fish that were located in the breeding tanks in the basement, as well as some of those that were just in the bottom of the very big tank, did survive and are still around and will be going to other programs and facilities owned by the same management company, the AquaDome organization that does this sort of work, as well as conservation and research work too. So the fish that were rescued were taken to the Berlin Zoo, the ones that did survive, and the saltwater fish mostly were taken to Sea Life, freshwater to Berlin Zoo exclusively, and that Sea Life is a Berlin chain located, like I said, in the same complex of the hotel there at the Radisson Blu. And the AquaDome was located as well in Berlin, but the other facilities have not reported damage enough to shut them down or anything. So that is good news. But early on Friday morning, late, I guess Thursday evening, is when the massive tank with 1 million liters of water just failed and spilled out into the freezing streets of Berlin. 16 meters tall, 52 feet. It was a giant mess in the capital of Germany. But luckily, the human toll is non-existent, and hopefully they can rebuild. Now, one thing that this has also highlighted is online a lot of people are talking about, should we even keep aquariums? You know, isn't this cruel to have fish swimming in a big circle all day and all these sort of things? And I think the fact that I've already pointed out that they're doing conservation, they're working on breeding fish in the facilities adjacent to that tank, and that they're pushing both engineering, filtration, and biology, and what we know how to take care of. You know, some of these fish may not even exist in the wild soon, with reef destruction and climate change and other issues going on. And it's groups like this that can charge admission for these things, that also impact many people, many children, and plant that seed of wonder and the kind of amazing joy that you get, and just the awe of seeing those beautiful fish swimming. When you can see large ones, you know, you can see a 1 or 2 meter long fish, a 6 foot, 7 foot fish, swimming around and enjoying something akin to its, you know, natural environment. So I know the first episode of the week's always the long one, and I want to tell you guys, we still don't know anything much about this giant, probably the biggest aquarium tragedy or failure that we've seen historically, with the exception of any situation where, you know, workers and things have lost their lives at aquariums in the past. But yeah, we don't know a whole lot yet. Hopefully we'll learn more with time. And thank you for sticking around. I know this is a longer one. Maybe you got an extra snack, or were able to go take a break from the morning show. If I'm not always your cup of tea, I hope you guys got yourself a cup of tea. So I will see you guys tomorrow, and I hope you have a wonderful day. Bye, guys. Hey everybody, what is going on? We are at episode 169 of FISHTORY, and we are going to be talking about the Pygmy Australian perch and how it was reintroduced, and it's a total success story. So there is this little pygmy perch, a little tiny perch, only a couple inches, an inch actually, in length, or about 8 millimeters in some cases, I guess, for the males, and then the females are somewhere around 2 centimeters or something like that. But they can be very small nonetheless. But they have had a bad luck of the draw, and in Australia, where these perch live in the Murray River Basin, their living situation had become untenable a number of years ago. So a population of the southern pygmy perch inhabiting the lower lakes region of the Murray-Darling Basin drainage would have locally gone completely extinct during the Australian Millennium Drought. So the Millennium Drought was a period of severe water shortages, started in 1997, and it went all the way through 2010. But fortunately, emergency rescue measures were undertaken, and they wanted to bring the remnant population of these little local perch into private breeding, tank breeding. And approximately 65 of the fish that were left out of probably 70 or 80 that were left in existence were collected, brought into a breeding program, and for the first time ever, they used DNA and computers and algorithms, and they utilized this information of testing the fish, finding the most different or diverse fish, and only crossing those fish with one another. And then once they have bred out a generation, they would allow it to go for several generations, and then someone else who had a different set of fish that were maybe the second most different, they would then cross every 3 or 4 generations. They would then switch brood stock and cross with one another. keeping their genetic diversity even more diverse than it probably would have been in the wild. In fact, it would make it the most maximally diverse biology and DNA that was possible statistically. So after they were doing all of this, the original inhabitants that came from those springs, these little fish, in the spring of 2011 and autumn of 2012, approximately 1,350 of the hatchlings of those original wild-caught fish had been bred and were let go back into the wild after over 15 years in some cases after being selected from the wild and bred. And the release of the first generation individuals that were the wild generation was important in reducing their time in captivity before they were let go, so that they would be able to adapt to the wild. And following the reintroduction, the demographics and genetics have been monitored very closely the last 13 or so years, 11 to 13 years, depending on which population. But every year they check on them biannually, and also they reintroduce more fish that are being bred in captivity still. And they recruit new additions to the breeding pool in captivity from the wild population, as well as are continuing to use their mathematical sorting program, essentially, to also keep the fish as diverse as possible, even though they started with those 65 fish. Well, now they're able to have a number somewhere akin to if they'd started with 20 or 30,000 fish, and they've actually kind of re-engineered the entire population. And they are also noting that the last 10 years that the fish have spread outside of the area where they were kind of last sequestered to, and they're going into neighboring areas that historically they were in. So alongside this successful population growth, all this information on the genome sequencing and how to prevent inbreeding and which ways to cross fish and what that means for their genetic fitness has been monitored really closely by lots and lots of different studies and different universities. So it had critically low inbreeding, and maintenance of the genome diversity was observed across 8 different generations in the restored wild population. They also found evidence that some wild ones that maybe when they thought were completely extinct, some survived because there was some new genetic material added to the pot, so to speak, that they couldn't account for. But kind of an interesting study, and it's definitely going to be a model that everybody looks to, whether it's for goodyieds or maybe even guppies and projects to breed other things that don't need to be let back go into the wild. But it's going to be very very good information about how to keep these fish from being inbred, from keeping it as diverse as possible. And when you see random mutations in a generation that are non-detrimental, judging whether that is the case, whether they're okay, and then allowing them to reintroduce into a population that is the most inbred that you have left, which is to say probably not that inbred the way they've been doing it. So they even are introducing more diversity as they see mutations in these fish, which they were sequencing a certain section of their DNA, each and every one, or each and every brood, and then charting out who they should be swapped with. So this is really interesting too, in that we could set up a computer program essentially to tell you with the CARES program or something like that, that, you know, you've got goodyids, you send in the sample of a fin or fin clipping, or a gill scraping, or a scale even, and you send it into the lab. $40 later, things are getting so affordable. You can look at it, you can get a printout of what your population's like, and then you would get info to know who would be the best person to swap your fish with, or to introduce to your line of fish to keep them diverse. So it really has a lot of applications in the future, but it's really the fact that they've proven 8 generations without management by humans, that looking at it in the wild, that they became more diverse again than they were ever known to be when they had been checked on. And even with old samples going back to the 70s and 80s, when they tested the genetics on that, they were far more inbred then. So they've really undone what had been done by probably climate change, you could say, but also just this drought that limited these fish to an area where they couldn't escape, and they were slowly dying due to a number of reasons. So a real success story, and a really interesting story that if you'd like to know more about, you can check out the Australian university that worked on that, as well as the government programs, and a huge list of professors and grad students and things. So pretty exciting stuff. I hope you guys have a wonderful day, and I will talk to you tomorrow. Hey everybody, and welcome to episode number 170 of FISHTORY. We're calling this one Mekong Damage. And this is out of Reuters. They posted an excellent interactive article that I found fascinating about the Mekong River and how its sediment and basically all of its flow has been butchered by the recent dam projects that China has been mostly behind. Now, there are other projects in other countries. Usually they're on the tributary of these rivers, but there are a massive amount of dams being built by China on the main stem of this up in the Tibetan Plateau. And this is where all the silt, the nutrients, all of the phosphates, and a lot of the nitrates and minerals and all sorts of stuff come from, for all the farmers and all the people, hundreds of millions of people in Thailand, Laos, Cambodia, and Vietnam. And so this is just an interesting article that's up, and I highly recommend you guys check out the link that's from it, because it's got all sorts of infographics that show where the water is flowing. I mean, even into Myanmar, and spots where it's not near the main stem of the Mekong, but it goes into watersheds that are affected by it, and it shows in actual infographics how much silt and fertile fill is being trapped behind these dams and not allowed to go downstream, let alone how the fish and things are cut off. So this plateau where the Mekong starts is in Tibet, and it runs to the South China Sea. And the Mekong River is a farming and fishing lifeline for tens of millions as it swirls through China, Laos, Myanmar, Thailand, and Cambodia before finally exiting and filtering out into the ocean in Vietnam. So the river is not bringing sediment and soil downstream anymore. And a farmer by the name of Chung, who didn't want to be identified by his first name, has grown rice for 60 years on his family's 10-hectare farm, and he said, without sediment, we are done. Life as we know it here is over. And he said that his crops have been steadily diminished, and now he barely brings in half of the 250 million dong, or $10,000 annually that he used to make just 5 years ago, and that his 2 children and several neighbors have actually had to leave the area and go find work in the city or somewhere else because the river can't support them anymore. So the dams, they're trapping sediment, and for decades scientists and environmentalists have warned these project builders in China of the likelihood of this happening. And out of the 18 million people that grow rice in the region as farmers, it's a economy of $10.5 billion, and it's a food source for over 200 million people in Asia, according to the World Wildlife Fund. Estimates and calculations by the Vietnam Chamber of Commerce and Industry has also said that the dam building, if it keeps going on, it has a rate of 7 new dams a year, and at least 4 of the 7 are being co-financed by Chinese companies in the near future. And China's foreign ministry said that the country accounted for only a fifth of the total area in the Mekong Basin, only 13.5% of the water flowing out of the Mekong estuary. So its responsibility was not to the lower residencies downstream, because the water gathered was from ground soil and sources downstream. But according to scientists in every place but China, the scientific consensus is that the overall impact of China's upstream dams is not addressing this dramatic decline in sediment and also in oxygenation and turbidity. So the value of energy from these dams and hydropower on the upper Mekong Basin is estimated by the Mekong River Commission to be $4 billion a year right now already, with that nearly doubling with these next 7 projects as they come online. So the hydropower stations in China are holding back precious sediment and water from 65 million people that literally live on the Mekong River, let alone the 200 million plus that are living in the floodplain regions of the river. And it's something very major to talk about. It's something that could start wars, could start, civil unrest, resistance, famine, all sorts of issues. And it's also going to impact a lot of species of fish, considering the Mekong is also home to 2 of the largest fish that are in fresh water. So the giant stingray as well as the Mekong giant catfish are both natives there and are likely going extinct. And this is not going to help at all when you get rid of the mud and this fine silt and things that gives nourishment to, the algae, the phytoplankton, the little micro crustaceans, and the whole food web, as it were. Now, on the river, they say that over 53% of the river's oxygenation and turbidity that kicks up this silt is on that 13% of river that is in Chinese territory of Tibet, which is arguably not China's territory, depending on who you ask. So it's an interesting situation. Now, also in Ethiopia, there's a similar situation with water. Sudan, Ethiopia, Egypt, all discussing water controls of the Nile and how dams are able to stop the movement of fish, but also oxygenated water and killing fish downstream, and making massive climate changes to desert areas when they make these huge reservoirs. Some of the biggest lakes in the world by area are behind dams. And so all of this brings up a lot of ethical and logistical questions, but it's something to watch, something to keep your eye on, and hopefully something that they can come to some sort of agreement on, rather than seeing 250 million people plus have to completely change their way of life, and let alone the 800 plus species of freshwater fish that inhabit the rivers and estuaries that are a part of the larger Mekong delta and basins. So keep following that, and check out that link on my page under the community tab if you're a member. Again, it's only $1.99, and it really helps me do what I do here on the channel and spend my time and energy resources researching this kind of stuff. A lot of this I have to have subscriptions to get a hold of, and so forth and so on, and just the time that it takes. But I love doing it. There's nothing I'd rather be doing, and I like to be able to get it to those who don't have the money to get a membership just as much. So that's why I release them all eventually, if not right away. But you know, thank you all for making that a possibility for those who don't have that $1.99 to spare right now. I really do appreciate it, and I'm sure they do. So I'll see you guys next time. Have a wonderful day, and I'll see you on FISHTORY tomorrow. And back to you, Jess. Bye. Hey everybody, what is going on? We are on episode number 171. Woo-wee! So, turns out that this living fossil of a fish that they found recently, I say found in a weird way because we knew it existed for the last 200 years. What we didn't know is that it was two different species. And just like cichlids are always getting switched around and recategorized by taxonomists and biologists, the same is true of all fish. Well, in North America, specifically in the United States, there is a fish known as the bowfin. And many of you on the East Coast, in the South, Midwest, Florida, you guys probably know about this fish. It's a very ancient looking fish with no shared lineage for over 300 million years that we know of. Its last shared lineages are with like bichers and coelacanths and all sorts of crazy other fish that look like dinosaurs, quite frankly. Paddlefish and sturgeon as well. And it turns out that where they thought that there was only one species, there are two. And so they're proposing that there's a separate species, one in the Mississippi River and the Ohio River, Missouri River drainage, and another everywhere east of that. So in Florida and Georgia, all the way up into like Delaware as well, too, with kind of an empty void of them not occurring in a lot of Appalachia. But these are a very interesting fish. A lot of times they get mistaken for snakeheads. They are a singular finned fish, dorsally and underneath, we'll say right now. But they basically move like a ghost knife fish or something like that, or an eel, and they are really fascinating to watch. They're really powerful, strong, muscular fish, and just ancient in the way they look. I mean, they really just look ancient too. They haven't changed a whole lot in 300 million years. So they're proposing that the common name for these two things, that they split it from bowfins or black bowfins to the ruddy or red bowfin and to the eye-tailed bowfin. And though the Latin names that they're suggesting are the Amia calva, and that's for the ruddy or red bowfin, and then the Amia ossilicata for the eye spot. Now, what's kind of interesting is that the word for the genus of bowfin, which before only had one fish in it, the bowfin, the name for that is Amia or Amia, and it is a Latin word that means prototypical or rudimentary baseline fish, like the shape of a fish, a basic fish. So it means tuna or herring, basically that fish shape that you see. If you were to draw a stick figure of a fish, that's what it means. So it could allude to any seagoing fish, or any swimming fish, fast swimming fish in Latin, apparently. sounds like there's not a super good translation for it, but it is an interesting name of the genus alone. And then the fact that they are naming the two new speciations that they're clarifying, the actual Latin names match very well to what they suggest the new common name should be, as I said. So the ruddy or red one, its name could translate to smooth or scalp, basically, and red also in ruddy. But the Latin name for the existing populations in the east are going by ammonia, and then the name that they wanted to say is ammonia ossilicata. Now, cadia, just like caudule, means tail or tail fin, and ossilia or ocelli, just like the word ocelot, means eye spot or eye spotted. So the fact that their common name is the eye spotted or eye spotted tail fin, bowfin, or eye spotted bowfin, is pretty spot on. The Latin matches for once. A lot of times, you know, Latin's all crazy. But despite reports from a recent study that looked at a number of specimens that had a very hard time figuring out like a set standard for telling these fish apart, they were able to tell the fish apart by DNA and genetics very, very clearly. So that doesn't help your average person so much. And so the two things that they've said you can tell these fish apart if you're out fishing, other than where it's located, but their ranges do overlap, is that a ruddy bowfin has 16 or 17 teeth on its left jaw, lower jaw, and the eye-tail bowfin will only have 15 teeth or bony teeth plates on its jaw. Also, there's a bone, so if you're able to do a necropsy on the fish, there's a bone in the hinge of the jaw, and one on the ruddy bowfin is kind of small, whereas on the other one it's almost L-shaped, and instead of being this kind of little trapezoidal shaped thing, it's almost a full L-shaped little jawbone lock that allows their mouth to open wider. But as for size, coloration, there's tendencies. The eastern ones tend to be kind of green and silver with a little bit of yellow. Sometimes some stripes, sometimes some dots, but sometimes they're jet black too. Like in Florida, I saw jet black ones there all over. And other times they're like copper or silver. And as a general rule, those greener and silver, yellow, those color tones will be on the eastern population that now is its own. And the red, rusty, copper, brown, black colors would be more frequent on the Mississippi bowfin species. All of this being said, counting those teeth on the left jaw. Now, they say left jaw, and I'm curious what that means. Like, does the right jaw differ? Do they have an asymmetrical mouth? I'm not sure. But, you know, what you have to count their back teeth, I guess, in the back left jaw to know for sure. And that's not easy to do unless you've obviously caught them, and then even then it could be a feat because, yeah, they can bite. So, hard to do while the fish is alive and know for sure, other than sending DNA off for a sample. But interesting nonetheless when we realize, holy cow, there's a species right under our nose. And in the case of this one, probably formed sometime in the last 13 million years. Could be as recently as 1 million years, but look likely they split off as the Mississippi River was forming in all Florida and all that came into its own and started having rivers like the Swanee and things. And that is the swampier location where those bowfins were able to evolve, and then the ones that are in the Mississippi, even though they do like swampy areas also, they evolved to swim up into totally fresh water, probably, and they probably became separated populations at some point when they lost their ability to go into brackish water and thrive there. So all really interesting stuff. They're doing the same thing with sunfish and like the red-eared, long-eared sunfish. There's so many sunfish now, and hybrids of the different sunfish, but they're no longer just saying there's a green sunfish and a long-eared sunfish or a pumpkin seed fish. Now they're recognizing in some cases there could be as many as 6, 7, 8 different species, and they vary by state, and it's a lot more than just the color patterns, which we already knew could vary immensely on a lot of these fish. But now we're seeing the genetics, like they've been separate for possibly 13 million years. That is pretty impressive. So we're constantly being amazed with what's right under our noses, even when we've had it described for 200 years in science. Question everything, guys. It's how we move forward. And speaking of moving forward, we are at the end of the week, so I hope you guys move forward to a wonderful weekend. Thanks for tuning in, and I will talk to you guys next week on FISHTORY. Thank you so much, and have a great weekend. Bye.